Right, hello. Today I'm going to walk through a GCSE maths paper. It's the paper 1 and the higher tier version, and it comes from AQA and the year is 2021. So let's get started. First one then, a to the 5 to the 3. When we have powers like this, we multiply them together, so that's a to the 15. X is not 0.4, circle the possible value for x. So we can see straight away this one, well that's going to be 0.4. Over here, we can cancel this down to be 2 on 5, and then multiply them both by 2, we get 4 on 10 again. So it's not that one. And the 120 on 300, let's divide by 10 to make 12 on 30. And then divide by 3 will give us 4 on 10 again. So all of these are the same, and the one it must be 26 on 70. Circle the solid that has 7 vertices. Vertices are like corners, so there's 8 of them on a cube, 4 on top, 4 on bottom. So for any prism, there must be the same amount on either side. So it's got to be an even number, so it's not any of the prisms. And we can look at the pyramid now. So hexagonal based, we'll have 6 on the bottom and 1 on the top for being like the very top of the pyramid. So it's going to be this one. 4. Here's a sketch of this graph. It's like a 1 on x graph, and what we'll be given the options to. Circle the equation of the graph. K is a constant. Well, all of these 3 are straight lines. So it's not any of these. It's got to be k on x. So write 200 as a product of prime factors. We'll split the 200 into 2 and 100. And the 100 into 10 and 10. And then each 10 into a 2 and a 5. So these are all primes now on the end. We've got some 2s, some 5s. We have 3 2s and 2 5s. Lovely jubbly. Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. Write Lily's age in months as a fraction of Hugo's age in months. Give your fraction in its simplest form. So we'll change these both to months. There's 24 months in 2 years. 24 plus 4 is 28. And there's 12 months in 1 year. Plus 8 gives us 20. We want Lily's age in months as a fraction of Hugo's age. So that means we want to do Lily on top of Hugo. So we have 28 over 20, which cancels down to be 14 on 10. And cancels down again to be 7 on 5. Use approximations to estimate the answer to this. So we'll say that's roughly root 100, which is 10. This thing we can say is roughly 2, which when we cube it is 8. And on the bottom, this is roughly 0.5. So altogether, we've got 18 on 0.5, which is going to be 36. Solve 5x plus 6 is greater than 3x plus 15. So we'll subtract 6 from both sides. And then we'll subtract 3x from both sides. And now divide by 2. So x is greater than 9 over 2. Write down the inequality that's represented by this number line. So it's something like this. 2 is less than x is less than 5. But we want to include the 2 because it's coloured in. So 2 is less than or equal to x, which is less than 5. Diagram shows an octagon. X equals 1 and y equals 5 are lines of symmetry, so the 2 dotted ones across. Work out q. So we can see that if we go across here, that's going to be 3. So we need to go another 3 across. So that would be positive 1 plus 3, which makes 4. So the same thing going up, we've got to go to 5 from minus 6, so that's 11. So doing the same thing, 11 plus the 5 gives us 16. Work out 2,000 times 70,000, give that to standard form. Well, this is 2 times 10 to the 3 times by 7 times 10 to the 4. So we've got 14 times 10 to the 7, which is 1.4 times 10 to the 8. Work out 1.8 times 10 to the 2 divided by 3 times 10 to the 1. Well, if we change the top to be 18 times 10 to the 1, then what we can do is just do the 18 divided by 3 and get 6. And then we'll have to do 1 take away minus 1 to get 2. So times 10 to the 2, leaving it as an ordinary number, so 600. A, B, C, D are junctions on a motorway. Distance CD is 3 times AB. Distance BC is 25, so that's 25 in this little part. Summer drives from A to C. She drives for 30 minutes, an average of 62 miles per hour. Work out the distance AD. So what this tells us is that she's gone 31 miles altogether from A to C. So only this little bit must be 6. The distance AD. So because CD is 3 times AB, that must be 18. So we add these all up. 6 plus 18 plus 25. Well, this is 24. So 24 plus 25. It's not a 5. Gives us 49. Here's a right angle triangle. Use trigonometry to work out the value of x. So we've got the hypotenuse, the opposite, and the angle. So that's going to be sine. Sine of 30 is equal to a half. So altogether, what we have is a half is equal to x on 10. So x is going to be 5. 13, convert 5 over 6 to a recurring decimal. I know this is just 0.83333, all recurring. But what we can do instead is think about doing 5 divided by 6 and use kind of the bus stop method. So we'll have 6 on the outside, 5 on the inside, but with lots of zeros. How many 6s go into 5? We've got none, remainder 5. How many 6s go into 50? We've got 8, remainder 2. How many 6s go into 20? We've got 3, remainder 2. And now because this is starting to repeat, it's just going to repeat forever and ever and ever. We'll get 3 again, 2 again, 3 again, 2 again, 3 again. So altogether 0.83 recurring. Simplify 3 on x plus 4 on x. Well, they've got the same denominator, so we can add across the top to give 7 on x. X plus a and x plus 3a is always equal to x squared plus bx plus 75. Work out the 2 possible values of a and b. So what we can do is expand this bracket. We'll get x squared plus 4ax plus 3a squared. And that thing then is always equal to x squared plus bx plus 75. So comparing the coefficients, if we look at the constants first, 3a squared is equal to 75. So that tells us that a squared is equal to 25. So a is equal to plus or minus 5, not b, 5. Looking at powers of 1, x to the power of 1, we've got 4a on the left is equal to b. So b is going to be 4 times our answers from a. So b is either 20 or minus 20. Cumulative frequency graph represents the masses of 14 necklaces. A jeweler buys every necklace with a mass greater than 21 grams. Use the graph to estimate how many she buys. So we want to draw a line up at 21. And then draw a line across from there. That gives us 16. But she's buying all the ones that are greater than 21. So we want to do 40 minus the 16 to get how many are above that, which is going to be 24. The lowest mass was 3, the highest mass was 28. Draw a box plot. So we'll put on the 3 and the 28. There's the 3. 28 is there. What we need now then is Q1, the median Q2, and also Q3. So these are the lower and upper quartiles. So to do that, there was 40 in total. So I'll divide that by 4 and go to 10. Draw across, draw down. That gives us something like 17. Do the same for 20. I realise the first one is not 17 but 18, but let me move this and then I'll do that. So 18, which is something like 17, but not quite the same. This one then is 22. Doing it for 30. Go across, go down. If you can do it by eye is okay as well, don't always need to draw the line. That's 24. So 18, 22, 24. 18, 22, 24. Now we'll go and draw our lines for those. 18, 22, 24. Now we join these on the top. And join these ones down the middle. Beautiful. Nice little box plot. Circle the vector that translates the point minus 2, 7 to the point 3, minus 1. So to go along here, if we look at the x-coordinates, that's a plus 5. Looking at the y-coordinates, it's a minus 8. So is there a plus 5 minus 8? Yes, there is. Here's a triangle. Give a reason why the side length AB cannot be 35 meters. Well, these two numbers are less than 35 meters. If you think like the only way that if this was 35, they would never connect. There would be no point C. They'd be like kind of just dangling down and never actually connect with each other. So we can say 17 plus 13 is less than 35. Here's a different triangle. Blah, 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 blah. We've got 31 millimeters, 54 millimeters, and 72 angle. Oh, and an angle X over there. Leah tries to use the sine rule to work out the sides of angle X. Here are the first two lines of her working. X over sine 31. Well, we need to put an angle in there, so that's not allowed. What error she made? Sine has to take in an angle. Angle. Lovely jubbly. Items made at a factory have to pass 2 checks. 90% pass the first check. Then the items that fail are scrapped. So this is going to be scrapped. Scrapped, double P. 99% of the items that pass the first check pass the second check. So this is 0.99. The items that failed are scrapped, so that's scrapped as well. Complete the tree diagram. So that's 0.1 to add up to 1 along here. And similarly, this is 0.01. An item is chosen at random before the checks. Work out the probability that the item is scrapped. So we can either go through and work out like both of these, or we can go through and work out this one and take it from 1. We'll do the first option. So we've got the 0.1 for the first bit, plus, to work out the probability of being over here, we have to do 0.9 times 0.01. So that is 0.009. And adding that on then gives us 0.109. So, skip me back a few pages. Quite a few pages. 0.109. Which of these is unit of density? So it's mass, so we've divided by volume. So we need to have mass on the top, which is grams. Volume on the bottom, which is centimetres cubed. So it's got to be this one. The first two terms of a quadratic sequence are 10 and 17. Here's information about the sequence. Work out an expression for the nth term of the sequence. So it's quadratic, so it looks something like an squared plus bn plus c. This plus 6 on the second difference is 2a. So a is equal to 3. We fill in the rest of the blanks on here. Adding 13 gives us 30. Adding 6 again to this makes 19. Adding 19 to 30 gives 49. Might not always need to do that, but it's no harm in doing it. So what we'll do now is build a little table. We'll have n. We'll have, which way round does it go? xn. We'll have an squared and then xn minus an squared. Don't need to do these cross ones. So n, these are the positions. 1, 2, 3, 4. We only actually need 3 of these, but we'll fill it all in. xn is just a sequence. 10, 17, 30, 49. An squared is just going to be the squares of these multiplied by a value of a. So 1 squared is 1 times by 3 gives us 3. 2 squared is 4 times 3 is 12. 9 times 3, 27. 16 times 3, 48. And now then, if we subtract the second row from the third row, so the 10, 17, 30, 49, and then take away 3, 12, 27, 48, gives us 7, 5, 3, and 1. And this then is going to be a linear sequence, and will actually be the bn plus c. So what we can do is say, well, this is minus 2, so this is going to be b, is equal to minus 2. And the c, I always like to go back to the original. So what we know, the first term, if we plug in all the things, so we've got a is 3, plus b is minus 2, plus c should equal the first term of 10. So c is going to be equal to 10 plus the 2 minus the 3, so that's 9. So altogether, 3n squared minus 2n plus 9. Work out the value of 5 on 7 to the power of minus 2. So the minus flips it over. So we've got 7 over 5 all squared. Squaring it, 49 on 25. And it wants it as a mixed number. So we have to think, how many times does 49 go into 25? Once. Remainder 24. And over 25 still. Rearrange this to make x the subject. So we'll reciprocate both sides. We'll have x plus 1 square rooted is equal to 1 on y. And square everything. X plus 1 is equal to 1 on y squared. And then we'll take away 1. So x is equal to 1 on y squared minus 1. F of x is cx plus d. F of 4 is equal to 7. F of 10 is 22. Work out c and d. So let's plug in these things. What does this give us? 4c plus d is 7. This goes 10c plus d is 22. If we do the second one, take the first one, we'll get 6c is 15. So c is going to be 5 on 2. Now plugging this back into either one of these, we'll do it into the second one, why not? We'll have 50 over 2 plus d equals 22. That's 25. And taking 25 away, d is minus 3. 24b. Circle the expression for hg. So that means we do g first and then stub that into h. So where the input to h is, we replace it with a 2x. So it should be 2x minus 1 divided by 2, which we've got over there. Show that this thing simplifies to an integer. So on the bottom, that's going to be root 6 straight away. And now let's have a look. Can we simplify root of 150? Well, what factors do we have for 150? 1 and 150. Hopefully there's a 6 in there, and there is. There's a 25. I look for the 6 because we've got lots of 6's already, and it might cancel off. So root 50 we can think about as being root 25 times root 6. Root 25 is 5, so that's 5 root 6. So altogether, 5 root 6 minus root 6 over root 6. All of these roots will cancel. What we're left with, 5 minus 1 over 1, which is 4. D equals 2f. And then we've got this thing, e minus f over d minus e is 1/4. Work out the ratio e to f. So we'll sub in our value for d instead of this. So we'll get e minus f over 2f minus e is equal to 1 on 4. We'll multiply the denominators on both sides. So 4e minus 4f is equal to 2f minus e. We'll bring all the f's to one side, all the e's to the other. So we'll have 5e is equal to 6f. And now the ratio will be the other way around. So e to f, where we've got the 5 by the e, think about plugging some numbers in. If you did e equals 5, you get 25. F is 6, you get 36. So that doesn't work. It's the other way around. E needs to be 6. F needs to be 5 to make them both into 30. So e is 6, f is 5. Vertices of a regular hexagon lie on a circle with centre O, radius 5 centimetres. Work out the area, work out the shaded area. Give your answer in the form of this thing. So first off, we'll work out the area of this little triangle. Area of a triangle, A is equal to half AB sine C. A is 5, B is 5, so that's 25 on 2. Sine C, so we've got sine 60. We know sine 30 was 1/2, so thinking about the patterns with the sine and cos, it's going to be root 3 on 2. So altogether, 25 root 3 on 4, and that's a triangle. So we say that there, area of a triangle. If we think about the big sector now, so I'll kind of colour it in blue around the edge, like the pizza slice shape, that's 1/6 of a circle. So the area of the sector is be 1/6 the area of a circle by r squared. R is 25, r is 5, square of that is 25. So altogether, we've got 25 pi on 6. And now the area of the shaded bit, well, we've got this sector bit, the blue bit, and we want to take away the triangle. So altogether, 25 pi on 6, take away 25 root 3 on 4. We want to have 12 on the bottom, so we'll do that. We'll have 50 pi on 12 minus, times this by 3, 75 root 3 on 12. And that's it. I'll write that just as one fraction quick. So 50 pi minus 75 root 3 all over 12. So A is 50, B 75, and C is 3. Right. Here's a graph of cos x. In parts A and B of the graph, cos x is shown on the dashed line. Draw the graph of x minus 90. So this moves to the right by 90 degrees. So instead of this being here, it's going to be there. So we'll go and dot some on there. That bit will be there now. This is there, there, and there. And remember, the graph is going to come up, go through this shape, something along this line. Don't have to be perfect with these, but as long as you hit those little markers, it should be okay. And making sure you do curved lines instead of straight ones. 1 plus cos of x. So this is up by 1. So it looks exactly the same, but we're going to go through all of these points, but keeping the same shape. Something like that. Just going to check that I draw this in the right place. I only wanted to draw it to 360, so I drew too far. There we go. Any more on this page? Yes. It tries to draw the graph of y equals cos of minus x. So this reflects in the y-axis. Here is our graph. Give a reason why Rita's graph is incorrect. Well, cos of 0 should be equal to 1. And cos of minus 0 should be equal to 1 as well, because there's no reflection. Well, there's a reflection, but it's the same point. It's on the line of reflection, so it's a invariant point. But here, she's got her one at minus 1 instead, so that's wrong. Here's a triangle, ABC on a grid. Describe this transformation on the grid so that point B is invariant. A moves to 1, 1. C moves to 1, minus 1. So we've got this triangle now, new little triangle. Describe the transformation. Well, we could either rotate it 180 degrees about B, or we could, is that right? Yeah, we could also do a transformation, an enlargement about B with a scale factor of minus 1. Either of these will work. Enlargement about B, scale factor minus 1, or rotate 180 degrees about B. Either direction, clockwise or anti-clockwise here. 180 degrees are the same thing. Is that it? End of questions. Lovely jubbly. Well, thanks very much. Hopefully that was helpful.